Hi there. Today we're going to be looking at lesson 756, and this has to do with um, subtracting with elevation problems. So remember, elevation has to do with how high up something is or how far down it is. The very first slide is to try to get us thinking here. They're asking us to solve the equations mentally first, and also to rewrite each equation as a subtraction equation. So when I'm looking at this, the first thing I'm noticing is that every single one has a variable, right? So this is called missing addend, and addend is the two things that you're adding, or it could be three, what you're adding up to get the answer for an addition problem. So when I'm looking at this, I know I have to figure out, for instance, the very first one, right? I'm figuring out if I have a total of 458, and I'm drawing a bar model to show this. If I have 458 total, so that's the answer, I know that I have to add 247 to some other number, which happens to be C. And if I add those two together, they total 458. So if I'm going to solve this, I know that I'm going to actually subtract. Now, this says mentally. I would like for you to try to find some methods on this. I'm going to tell you what my method is, and you can choose to use that or not. Okay? Mentally, a lot of times students like to try to solve it in the traditional method, which might look like this. So I know to solve this problem, I actually have to do 458 minus this, so 247, in order to get C, right? So we would subtract. And a lot of students try to put this mental picture in their head. And that's fine if that works for you. I personally have a hard time keeping track of everything. So what I personally do is I add little bits until I get up to the total, right? So for instance, here's what I mean by that. I know I'm adding a number to 247. And what I like to do is think about how could I count up easily, right? So like for instance, I'm looking at that and I know already, well, if I have 247, if I add 100 to that, because I can easily add on hundreds, I end up with 347, or right? Whoops. And then I can add another 100 onto 347, and I will have 447, which I know now is pretty close to what I'm looking for. So I'm at 447, and I've already added 200 on to my original amount, right? So I'm still trying to get to that target, 458. So I'm thinking, what do I add to 447 to get to 458? So from there, I like to use what is called sums of 10. Um, And I know that if I add 3 to this, I get 450, right? And I did that by using that sum of 10. 7 plus 3, I know together makes 10. So that's going to bring that up to 450. And then from here, I know I just have to get to 458. So if I add a total of 8 on, I end up with my target of 458. So now I just have to remember, what did I add on? So I knew I added on 200s, right? So 200 plus a 3 and plus an 8, and 8 and 3 is 11. So I know that I added on 211. And look, that's true. That gets me there, okay? So I can do the same thing here. Here we have a decimal, which, a lot of times that does kind of make people think, oh no, I'm not sure how to do this. But it works the same way, right? So for this one, I know that I have to add something on to 400 or 43 and 87 hundredths to get to 58 and 92 hundredths. So again, I am going to add, in this case, I know I'm going to add some whole numbers. Well, can I add 10? That's where I would start. If I add 10 onto this, so just 10 wholes, right, or 110, however you want to look at it, I know that that's going to give me 53 because it's just going to change that number in the tens place. So it's going to be 53 and 87 hundredths. Okay. I'm getting a little bit closer. Now I want to try to get, what if I can make this a whole number? So if I go ahead and add on, if I add on 300ths, again, I'm using sums of 10. It's very helpful in our number system. So I'm going to add on 0.03, and that's going to take me to 53.9, right? If I add on 300ths, it's going to bump this up to 0.9. And then from here, actually, I'm going to keep this here because I'm noticing my ending needs to be a 0.9. All right, so if I add on 5 wholes, I end up being at 58.9. That's pretty close. And now all I have to do is add on that 200ths. So 58.9 plus 0.02 is what's going to get me to my final answer of 58.92. And then again, I'm just remembering, what did I add on? So I added on 10. Let's see. I know I added on together. There's 500ths, right? And I also added on a 5. So that's 15 and 500ths. So let's try that out and see if that works. 15, and notice I have to put a 0 here to show that there's no tenths that I added on, and that does add on. Cool. So the next one, the last one for this part, is a fraction. So again, I know I'm starting with 15/8, and I have to add on to that until I get to 51/8. This one seems a little bit easier to me than a normal fraction problem because we're starting with common denominators. So everything's chopped into eighths, so that's easy. I can just add on to this. So how can I get from 15 to 51, basically, right? So let's see here. Well, I could add, now you could start by adding tens, right? So I could do plus 10/8 is 25/8. But I know that I'm going to start, if I added 40, let's try to add 40 so I can get to 50, right? So if I add 48ths, let's see where that gets me. Let's see, 48ths would be 40, 55. Ooh, that's too much. So I guess I can't add 40 on. So why don't I try 30? Let's try 38ths. Because if I add 38ths, that's going to give me a total of 30, 45. So 45/8. Okay, which is close to 51/8. So now I'm going to do my sum of 10, right? I'm going to try to add 5/8 on because I know 5/8 added to 45/8 gives me 50, right? So 45 plus that 5 is 50/8. And then that means I have to add on just one more eighth to get to 51. All right. And again, I'm just going to, whoops, that's an eighth. I'm just going to add up how many did I have to add on total to get the answer 51. So I know I did right here, that's 5/8 and 1/8, that's 6/8 plus 30. So I know I added on 36/8. And I get the right answer there. Okay. Now, the last thing that they're asking us to do here is to rewrite these addition as subtractions because we actually did use subtraction to solve these, right? So I know in order to solve that problem, I did 458 minus 247. And that gave me C. All right, cool. For this problem, again, I had to take my total, the 58.92, and I subtracted 43.87, to get C. Remember, these are equations, so there is an equal sign in the answer. And for this one, we actually did 51 eighths minus 15 eighths to get C. Whoa, that's not what I was trying to do, is it? So this is where it's important to pay attention here. So let's see here. 51 eighths, there we go, minus 15 eighths equals C. All right, very good. And I never did hit submit, but there we go. So let's take a look at our next one. So for here, this is very much like one of the problems or slides that we did last week or before. So we're using altitude. Altitude is just how high up somebody is. It's kind of like elevations, right? So elevation, how high up somebody is. And we're looking at our mountaineer who's climbing up a mountain. And here we have our beginning elevation, we have the final elevation, and then the difference between the two, and then the change. So let's kind of take a look at this very first one here. We have, and I'm just going to simply show on my number line, right? I know that we started at 400 feet. So I'll put that in. And then I also know that the final elevation was 900 feet. And these are both positive. So that, let's say this is 0. 900 is going to be up here. Now, when we say they're asking what was the change. So the change is really saying how far apart are these, right? What's the difference between the two? And if I wanted to know, so this is the change, I'll put C for change. If I wanted to know how far apart these are, I would just take the 900, right, and subtract 400. If I take 900 minus 400, it'll show how much did we go up. And so we know that 900 minus 400 is 500. Okay, so let's try this one. It's going to work the same exact way. Here's my number line. We know that we start at 400 feet. This time I'm noticing that the elevation went down to 50. It's still positive, so there's 50 feet. So again, we're looking for what is this amount here, right? So to solve this one, I would take the 400 minus 50. All right. That's the subtraction. Notice in this case, we just take the highest number minus the lowest number here. All right. And so I know 400 minus 50. Well, you can do this. If you can do it in your head, that's great. If not, do it traditionally. I know the difference is 350 feet, except I forgot to do something. So this is saying it's wrong. So now we have to decide, was the change positive or negative, right? I know if we started here and went here, it went down. So that means that is a negative change. So I have to show that in my answer. So let's do that. And the answer, negative 350, is still not right, which is interesting because it should be. One thing that I've noticed is that when I put in 400 minus 50, I actually still have a red X. And when we take a look at this, 400 minus 50 does not give us the change of negative 350. So really, this is the problem. It's our difference, our subtraction problem here. And actually, what we end up doing, just like in our warm-up page here, if we want to find out what we're adding to our starting amount to get a final amount, we actually end up taking the final and subtracting out the starting amount, and that gives us a change. And we did this for all three of our warm-up questions. So let's take a look at this one again. Only now we started at 400 and ended at 50. So we're actually going to need to take our ending amount of 50, take away our starting amount of 400, and that actually does give us the answer of negative 350, because 50 minus 400 is the same thing as 50 plus negative 400, which is negative 350. So now let's take a look at the next problem. So again, we have a final elevation of negative 120 and a starting elevation of 400. We need to figure out what is the change, and this here is the C, the change. And in order to find change, we're going to take the ending amount, so the negative 120, and we're going to subtract the starting amount of 400. So now we have to figure out, well, what is that amount? So if I start with negative 120 to get to 400, well, that's the same thing as negative 120 minus 400. We actually can change this to an addition problem, right? Because really we're taking, what's the distance from negative 120 to 0? Well, that's 120. Plus there's another 400 here. And so we're really doing negative 120 plus negative 400. And so I know total, that's 400 plus another 100 is 520. And I do know that this is negative because both of these are negative and my change is going down. So our total ends up being negative 520. All right, next problem. We have a starting elevation of 200, negative 200, and our final elevation is actually 610. So it's way above the initial. So our change we know is going to be positive because we're going up. So to find that actual number, again, just like the others, we're going to take our final elevation, we're going to subtract the beginning elevation, and that gives us this change here. So the math problem is 610 minus negative 200. Now, when actually solving to find out the change, I'm noticing here, if I start with a positive number and I take away negatives, so that's like saying on my hot air balloon, I take away 200 sandbags. If I take sandbags away, we're actually going up. So this problem is the same thing as doing 610 plus the opposite of this number, which is 200. So I know 610 plus 200 is actually 810, which doesn't match up. It should be a positive number. So let's put that in. And it does work out. So next up, we have a beginning elevation of negative 200. And then a ending elevation of negative 50. So again, I know my change is actually going in the positive direction. So to solve this, we actually take our ending elevation. So we're going to start with our ending elevation of negative 50, and we're subtracting our beginning elevation of negative 200. And to solve this problem, I know that taking away sandbags is actually the same thing as adding puffs of air. So it's the same thing as adding the opposite to this number. And so when I solve this, I know that I'm actually subtracting, right? So 200 and getting rid of 50 negatives, I'm going to end up with positive 150. So here's my answer. All right, let's move on to the next problem here. I have a starting elevation of negative 200, an ending elevation of negative 500. And we're looking for the change, which is from here to here. So how far is this? I already know it's going to be a negative number. And solving my problem, it's going to look like my final elevation of negative 500 minus the starting elevation of negative 200. And I also know that this is the same thing as taking that negative 500 and adding the opposite of 200, of negative 200, which is positive 200. So the difference here is negative 300. That did end up working out for us. So let's move on to the next one. For this one, we're starting at negative 200 on our number line, and we actually end up at 0. So we know that our change is going to be positive because it's going up in elevation. I'm going to take my ending elevation, my final elevation of 0, and subtract my negative 200. I know I can turn any subtraction problem to addition simply by starting with the same amount and adding the opposite. So I'm adding 200, and 0 plus 200 is simply 200. So let's check that out in the answer. And it does work out. All right, so let's check out the next slide. Okay, this is an Are You Ready for More? I'm not going to show you all of the solutions, but I am going to get you started. The directions say fill in the table so that every row, rows go left and right, and every column up and down are sums of 0. And sum is simply the answer to an addition problem. So when I'm getting started on this, the first thing I'm noticing is I don't really know what this is going to be because I have 2 open spots, but I for sure can fill out what this one is because I noticed I have everything except for 1. So I'm going to go ahead and try these out. So I know I'm going to add up what I have. So 5 and 25 is a positive 30. Those together are 30. And then a negative 12 and a negative 18. These actually make up negative 30. So I know together these 4 actually are 0. And so what do I add to 0 to get 0? 0. And from there, now I should be able to fill in this box because I have these. And eventually you should be able to fill in all of the missing pieces, solving box by box. So see how you do. Okay. For this side, we're simply going to fill in, it says find the value of each subtraction expression. So here are the expressions, and the value is really just their answer. So that's your first part, to try to add those up, or subtract to find the answer. When I do 3 minus 2, that's a simple one. It's just 1, right? 5 minus negative 9, well, since I'm subtracting a negative, I know I can actually add the opposite. So adding the opposite would make this 5 plus positive 9. So 5 plus 9 is a total of 14, and that checks out. Same thing here, negative 11 minus 2. Well, that's the same thing as negative 11 plus a negative 2. And so I know negative 11 plus 2 more negatives is a total of negative 13. Okay. Solving here, same process. Negative 6 minus negative 3 is the same as negative 6 plus the opposite of negative 3, which is positive 3. Since I have a positive and a negative, I know that these are going to end up canceling each other out. So 3 positives cancels 3 negatives, and that leaves me with 3 negatives, negative 3. Even though these are decimals, it still works the same way. This problem becomes negative 1.2 plus the opposite of 3.6 of negative 3.6, which is positive. And now again, I have a situation where I have a negative and a positive. So I know to solve that, I'm going to have to take my 3.6 and subtract out 1.2. So my answer ends up being 2.4. And it is positive because there's more positives than there are negatives. And finally here, we have negative 2.5 minus 3.5, negative 3.5. So this is the same thing as negative 2.5, adding the opposite. So that's positive 3.5. So in the end, I'm really finding the difference. What's the difference between a positive 3.5 and the negative 2.5 is 1. And it's going to be a positive because there's more positives here. The answer is simply 1. On the other side, we're doing the same thing. We're finding the value of each expression. On this case, I'm noticing that every single one of these is the opposite of over here. So this was 3 minus 2. This is 2 minus 3. This was 5 minus negative 9. This is negative 9 minus 5. So they're just flipping the order. So go ahead and solve these in the same exact way as these and check out your work. So now that I've completed my table, I've showed my work for the second part here. I'm actually looking at the question up here is, does the order matter? And what I've noticed is if you flip the order of subtraction problems, your answer is the same except for it's the opposite sign. So 3 minus 2 was 1, but 2 minus 3 was negative 1. And that happened for each and every one of these problems. So if you flip the order of a subtraction problem, you'll get the same answer for a number. It's just the sign will be the opposite. Okay, and that's what I want you to put in here. All right, so go ahead and sum up your answer here. When I explained what was happening, I made sure that I put an example in each explanation. This helps you explain what's going on in the problem. All right, next up. So we're going to just synthesize. That means we're going to put things together of what we did. All right. So for every value of A and B, how will the value of A minus B compare to the value of B minus A? So again, this is like what we were talking about on the last slide. If A is 3, B is 2, whoops, then the answer ended up being the opposite. Whoops, that was positive 1. This is negative 1. So the answer is that they're opposites. So what's the difference? Difference means the distance between 8 and 3. So the distance here, the difference is 5. That's showing that the difference 8 minus 3 is 5. Here, what's the distance between 3 and 8? Well, I can use what I learned here to answer this. It's the same thing except it's flipped, so that means the answer is going to be a 5, but it's negative 5. What's the distance between 8 and 3? Positive 5. What's the distance between 3 and 8? Well, the distance, no matter what, is the same size, so that's going to be just positive 5. And we've completed it. Here, you're going to go ahead and put your name in and the date. And then you're going to check out which operations would you like to practice, and this is going to give you some practice problems. You can check all of them if you like. We've only done addition and subtraction so far, so that's all I'm going to select. And you're going to go ahead and do some problems until it tells you to stop. And once you're done, it's actually going to show you all your answers here. Okay? So good luck with that.